In this video, we will learn how to find out the level of output where average cost is minimum. The question is given total cost TC is equal to Q cube minus 10Q square plus 6Q, where Q is the output, TC denotes the total cost. We need to find out the level of output where average cost is minimum. Okay, so we have the total cost function is Q cube minus 10Q square plus 6Q. Okay. Now, first we need to find out what is the average cost. Average cost is the total cost upon the output level. That is, total cost is Q cube minus 10Q square plus 6Q. To this we divide by Q to get the average cost, which will be equal to Q cube divided by Q minus 10Q square divided by Q plus 6Q upon Q. That gives us average cost will be equal to, so here we have the Q square, 1Q gets cancelled. In the second term we have 10Q, and in the last term we have 6. This is our average cost. Now for this average cost to be minimum, what we do, our derivative of average cost with respect to output should be equal to 0. That will give us the minimum average cost. That is to say, if we have the output on the horizontal axis, average cost on the vertical axis, so let us say this is our average cost function. Now average cost will be minimum when the slope of the average cost is equal to 0. Okay, so that means the derivative of the average cost function with respect to output gives us slope. Okay, so first derivative gives us the slope, and where slope is equal to 0 will give us the level of output where average cost is minimum. Okay, now let's take derivative of this function with respect to Q. Derivative of Q is 1, so we are left, derivative of Q square is 2Q minus derivative of Q is 1, so we are left with 10, and derivative of a constant is 0, and we set it equal to 0. Okay, to get the slope equal to 0. That gives us 2Q is equal to, transpose it here, it becomes plus 10, dividing both sides by 2, so we will get Q will be equal to 2 1s are 2 5s are 10. That means our average cost will be minimum at the output level of 5 units. I hope I make myself clear. Thank you.